Hi, and welcome back to Grade 8 Math. This is Section 3, Lesson 1, and the first video for this lesson. This is Ms. Clemens-Brenton, and in this video, we're going to look at the difference between theoretical and experimental probability. Probability is the likelihood that something will happen. Theoretical probability is what we expect to happen without actually conducting an experiment. We would calculate theoretical probability by writing the number of favorable outcomes over the total number of outcomes. For example, the likelihood of a fair coin landing on heads would be 1 out of 2, since there is only one head on a coin, but two different possibilities. We could get heads or tails. What this means is, whenever I toss a coin, I would expect to get heads 50% of the time and tails the other 50%. So if I was to toss a coin 4 times, I would expect 2 of those to be heads. What we expect to happen, however, is not what always happens. For example, I could toss a coin and get tails. I could toss that coin again and get tails again. And I could toss that coin 2 more times and still get tails both times. This is what we call experimental probability. Experimental probability is what actually happens during an experiment. Experimental probability is written as the number of times an event occurs over the total number of trials. For example, the table shows the results after a coin was tossed 20 times. The experimental probability for tossing heads in this case would be 13 over 20, because when the coin was tossed 20 times, it landed on heads 13 times. A spinner is shown. What is the theoretical probability of spinning blue? I would write P of blue, which simply just stands for probability of getting blue, is equal to the number of sections that are actually blue, so there's one blue section, over the total number of sections, which is 5. There are 5 different sections on that spinner. What is the theoretical probability of spinning red or green? So I would write probability of red or green, so P of red or green, is equal to the number of sections that are red or green, so I can see we have 2 sections, and I write that over the total number of sections on the spinner. If the spinner is spun 25 times, how many times would you expect to get a color that is not yellow? So the probability of not getting yellow is 4 over 5, because there are 4 sections there that are not yellow, since there is one yellow section. And then I would write an equivalent fraction and figure out how many times that would be out of 25. So 5 times 5 would give me 25. So 4 times 5 would give me 20. Example 2. Elise spun the spinner 60 times and recorded her results in the table. So because she actually completed the experiment, this would be experimental probability. What is the experimental probability of spinning yellow? So I would use the information in the table to determine the experimental probability. So over here I can see she landed on yellow 10 times. So the probability of getting yellow would be 10 out of a total of 60 times that she spun the spinner. I would then reduce that to 1 over 6. So I would divide each of these numbers by 10 to get 1 over 6. So the experimental probability of getting yellow is 1 over 6. What is the experimental probability of spinning red or green? So again, I would look at the table. So the probability of getting red or green, I would add up the number of times that she landed on red or green. So 16 plus 8, that would give me 24 over a total of 60 times that she spun the spinner. And then I would reduce my fraction. So that could reduce to 12 over 30. I could reduce it again to 6 over 15, and I could reduce it again to 2 over 5. So the probability of getting a red or a green was 2 over 5. Which color has an experimental probability that is the same as the theoretical probability? Well, the theoretical probability of landing on any of those colors would be 1 over 5. So the probability of a color, of just landing on one, would be 1 over 5. Because each color is there one time out of a total of 5 sections on that spinner. So in looking at this table, I would have to determine which color had an experimental probability that was the same as 1 over 5. If I was to write each of them as a fraction, this one would be 14 over 60. I know that's not 1 over 5. 10 over 60, we just determined that that's equivalent to 1 over 6, so that's not 1 over 5. And 12 over 60, I know if I reduce that, I get 1 over 5. So it would actually be blue, because 12 over 60 is equivalent to 1 over 5. Example 3. Kira selects one card from 7 cards that are laid face down on a desk. What is the probability that she will pick a G? So I write probability of picking G. I determine how many G's are in that pile, so I can see 1 G, and there are 7 cards in total. So the probability of picking G would be 1 over 7. What is the probability that she would pick a vowel? So the probability of picking a vowel, so as a refresher, vowels are A, E, I, O, or U. So I look through those cards and I determine how many vowels that I have. So I have an A and I have an E. So there are 2 vowels there. So I have 2 over 7. Please proceed to the next video for this lesson.